Hey kids, it's Mr. Yo, your science bro. So today, let's take a trip to the particle zoo. Matter, all matter, is made of particles. Well, let's investigate this, shall we? As soon as we talk all matter, we also have to include something called antimatter. And all particles have an exactly opposite particle called its antiparticle. So, sort of a subnote to all matter is made of particles. There's also, for every particle, an antimatter particle. Okay, good to know. We group particles based on what forces they can feel. Okay, so how do we group that? Well, first, understand there are four forces. Gravity. All matter pulls on all other matter. Electromagnetic force. These are where opposite charges attract and like charges repel. And then we have nuclear forces, of which there are two. The strong nuclear force, and that is that nuclei, the residents of the nucleus in an atom, they attract each other strongly. That's why we call it the strong force. And the weak nuclear force is what causes radioactive decay. Like when a neutron shoots out an electron, becomes a proton. That's like your carbon-14 decay. So these are the four forces, and particles are based on which forces they interact with. So we have two groups of particles. First one is hadrons. Hadrons feel all four forces, and all hadrons are made of smaller particles known as quarks. Leptons, they feel three of the forces, but they do not feel the strong force, so they don't play in the nucleus. Leptons are not made of smaller particles, so they are fundamental. You can't break a lepton in half. So the typical particles that we see, hadrons, they're the ones that make the protons and neutrons in an atom. Leptons, they make the electrons. So they make other particles as well, but the ones that we see in our normal world are those. So we break the hadrons down further into two other groups. The baryons, these are the heavy hadrons, the heavy particles. They are each made of three quarks, and they make the protons and neutrons. So the baryons are the important ones for us. They make baryonic matter, and that makes up the world we see. Mesons are the medium mass particles. They're made of a quark and an antiquark. Remember that antiparticle thing? They're made of a quark-antiquark pair, and we don't meet these in ordinary life. So of the hadrons, baryons are the important ones for you to know. Well, what is a quark if we're making up hadrons with quarks? Quarks are a fundamental particle. We found that we could break the hadrons further down. Quark is the fundamental particle. They cannot be broken down into smaller particles. And weirdly, quarks are fractionally charged. You have either negative 1/3 electron or positive 2/3 electron. But they always travel together. They cannot be broken into fractional charges. So while we understand that this is how the quarks work, we never meet quarks by themselves. All baryons are made of up and down quarks. Okay, so remember, hadrons are broken down into baryons and mesons. All the baryons are made of up and down quarks. The up quark has a positive 2/3 charge. The down quark has a negative 1/3 charge. So pretty neat. So the baryons can be made into protons if you add an up, and a down quark. That's 2/3, positive 2/3 plus positive 2/3. That's positive 4/3 minus 1/3. That's a down quark. That equals 1 electrical charge. That's that 1.6 times 10 to the minus 19th coulomb. That is a proton. Okay, an up, and a down quark make a proton. Similarly, you could take a down, and an up quark, and that turns into a neutron. And that would be negative 1/3 plus negative 1/3 plus positive 2/3. That is 0 charge. So baryons make up protons and neutrons. And simply with two kinds of quarks, we can make both the protons and neutrons. The leptons don't feel the strong force, so they are not in the nucleus. The typical leptons are the electron, of course. It's -1 electrical charge, or E minus. The positron, which is an anti-electron, and that would be E plus. And then we have the neutrino. These are very, very, very tiny masses. They almost never play with other matter. Vast quantities are made in the sun. Huge quantities are passing through you right now. These are the neutrinos. But the typical lepton that makes up the matter that we mostly care about is the electron. So let's put it all together. All atoms are made of two kinds of quarks, the up-up down or the down-down up. That's making a proton or a neutron, but just two kinds. The up and the down quark make all of the protons and neutrons we ever meet. And all atoms are made of only one kind of lepton. That's the electron. So two quarks, one lepton make all the matter we ever see. Here is a helium atom, and you see the protons and the neutrons and then the electrons. And it's simply up, down quarks, and a lepton, and that makes all the matter we've ever seen. So all normal matter is made of one lepton and two quarks. So if we look at our reference tables, let's put this together with our reference tables. We have there's 6 quarks, aren't there? We have the up and down quark, you can see their charges, but then we also have the charm and strange quark, and the top and bottom quark. Interesting. Leptons, we see the electron, the muon, the tau, and then we have 3 kinds of neutrinos. Interesting. But what we need to make all the matter are up, down, and the electron of the leptons. That makes up all normal matter. Okay? Remember that matter is then made of hadrons and leptons. Leptons are fundamental, so you can't break them down. Hadrons can be broken into baryons. Those are the heavy ones that we care about because they make the 3 quarks, the protons and neutrons. The mesons are the quark-antiquark pair, not too common. So the question would be, why are there 12 particles? Well, why are there 12 particles when we only need 3 to make up the entire universe? It says, see next page. I guess we have stuff to learn still. And we don't know why there's 12 particles. Someday, maybe, somebody will figure that one out. But that's how matter works. Thanks for watching.